pathogens are constantly moving through the air.
In hospitals, schools, workplaces, and public indoor areas long before they ever reach a surface. Microscopic particles remain suspended in the air and shift with movement, airflow, and activity. In invisible light, Far-UVC interacts with microorganisms but does not penetrate into the living layers of human tissue. This allows Far-UVC to inactivate airborne viruses, bacteria, and multi-drug-resistant organisms while rooms remain occupied. Airborne concentrations decreased by up to 98% in controlled room experiments that were peer-reviewed and published in the Nature journal Scientific Reports. Achieving similar reductions with ventilation alone would require between 36 and 180 equivalent air changes per hour. Studies have shown in healthcare environments, airborne organisms of concern including MRSA, Candida auris, and others can be decreased by over 99% when Far-UVC supplements the existing ventilation and filtration. Ultraviolet germicidal irradiation has a long history. Published epidemiological studies over the past 85 years, including 19-year studies, documented infection reduction rates of more than 66% during periods when traditional systems were active.
This foundation supports modern interest in Far-UVC.
Far-UVC is now being used as an added engineering layer for improving indoor air quality across many public environments. Grounded in physics, biology, engineering, and peer-reviewed published research, Far-UVC represents a pathway toward cleaner indoor air. Far-UVC is going to be in all public spaces eventually. But why wait, when you can start inactivating harmful pathogens in the air right now?